Hello, this is Jay McCarthy from PrimeVault in our architecture series. Now, today I'm going to talk about one of our strategies for providing security guarantees. In earlier episodes, I've talked about our use of enclaves. At a high level, an enclave is a computational black box that runs code that we know hasn't been tampered with, and we know what code is running. We know that it really is version 1337 of our software, and that version corresponds to some particular code. That's great, and you can be sure that in a situation like this, your code hasn't been tampered with by hackers. But you don't know just from using an enclave that the code is any good. As an analogy, imagine that you're going to hire a babysitter, and this babysitter is going to be in your house with your kids when you're not there. They can do anything they want in your house, and your kid's safety is in their hands. In a situation like this, you don't merely want to know that the babysitter is the same guy that it was yesterday. You want to know that he's actually a reliable person and that he's going to do what you want and that he has high moral standards and is reliable. You don't merely care that it's the same DNA as the last time you hired him. You actually care about the content of his character, not merely that he's the same person. Now, enclaves, they only establish that you're talking to a particular version. That means that you know when you use an enclave that it really is Guy Fawkes, the babysitter, and not Sly Fox, the babysitter, who's wearing a Guy Fawkes disguise. Now, just as an aside, our competitors, they don't even do this. When you use the policy engine for some of them, you submit transactions and you have no idea where they're going. They make no claims whatsoever about what software is running on the other end, when it was last changed, what version it is, anything. Anyways, back to our analogy. So enclaves, they establish just that it's the same person it was yesterday. But that's only useful if you know that the person is a good person. So how do we know if software is right? This is a major problem in the history of computer science, to know if software is reliable and doing what we want. Now, there are a lot of different strategies for ensuring that software is trustworthy, and I'll talk about a few of those. So, one thing that's intuitive to lots of people is testing. What is testing? What does testing even mean? Testing means that I wrote a program and I ran it a bunch of times and I like the results. So the program, it takes a number and it returns a number. So maybe I called it with 7 and I got back 42, and I called it with 6 and I got back 36. I like these numbers, therefore I like the software. That's what a test is. And one of the essential problems with testing is that A, you can only do a finite number of tests, and your program is probably going to run in an infinite number of situations. And then B, how do you know that the tests are any good? Why is 42 the right answer when you send in 7, and why is 36 the right answer when you send in 6? These two issues are the fundamental problems with testing. How do you know that you tested the right things? And how do we know that those are that the system is going to behave correctly in the situations that you didn't test? So, how do you get around this problem? One thing that's really common in the world of blockchain is the security audit. Now, if we get away from all the subterfuge and peacocking in the audit business, what is an audit really? An audit is someone saying, "I'm smart. I've looked at this code and I like it." That's really what it is. It's the quintessential proof of authority. Someone, the auditing firm, has authority because they have glamour and trust, and they have attained that through, a whole bunch of inscrutable ways, and they sell that authority and trust to other people. So I go to them and I say, "Please audit my stuff." They look at it and they say, "It's good." And they offer nothing more than their reputation. Because if they start saying that things are good when they're not really good, then they get found out and then they lose their future income stream. And so that salesmanship of reputation is what the auditing industry is really based on. And are there any better options? Now, in the real world, like the physical world beyond blockchain, a really common thing to solve this kind of problem is to offer insurance. So, as an analogy, an auditing firm, one of the things that it might do is it might say, "We think this is good, and if anyone finds a problem with it, well, we'll pay them $1 million." The cryptocurrency world, it kind of does this backwards. Bug bounties are typically paid by the person who buys the services of the auditing firm, meaning that, PrimeVault, we would hire, the XYZ auditors to audit. XYZ would say it's good. And then PrimeVault would show off by saying, "By the way, if you find an error, we'll give you $100,000 or something like that." When really that $100,000 should probably be paid by the auditing firm. What this does is it makes it so that in addition to losing their reputation, they lose money when they give bad audits. And of course, their rate at which they charge for audits would be related in some way to the payoff that they would expect. This is essentially how consumer electronics provides safety standards in many countries in the world. But nevertheless, that's not common in blockchain. We're not doing that because we don't really have anyone that works that way. So, anyways, the reality of ensuring that software is correct right now, it's not great. Um, I want to talk about formal verification, which is the main thing that PrimeVault does. But I think that that's going to take kind of a long time. So what I'm going to do is I'm going to split the video here, and then I'm going to record another one that will go into like a deep dive on formal verification. But this is just sort of like an outlay of the problems that we see with like the common practices of testing and audits and why we do something more than that. But I'll get into the details of what exactly that is in the next video. So hang tight, and I'll see you in the next one.